Calculus!
This is AP Calculus Self-Check 3.1. I am homesick, so if I make errors, I'm going to blame my sickness, of course. So let's go over the answers really quick. I already assume that you have done all 6 problems in 12 minutes. So number 1 was B, number 2 was E, number 3 was B, number 4 was E, number 5 was C, and number 6 was C. So go ahead and feel free to move around the video as you see fit to learn how to do these problems. For number 1, we have a graph of f prime here, and it's shown on that interval. On what intervals is f increasing? So again, what's the definition of f increasing? It's where f prime is greater than 0. That's the definition that you should have at the tip of your tongue. You'll notice that b is not quite how we write them in class, because at 1, the derivative of f prime is 0, the height is 0, which means you should really be writing it differently. You should be writing it something like -2, 1 union 1, 3, like that. But I think that's as close as we're going to get. This is not, I don't think this one is actually taken from the AP test. That's why it's a little bit off. So if you thought that it was none of them, then I'm there with you. I agree it should be this way, but this is as close as we're going to get. Number 2. We have a graph of f prime, and we're looking for inflection points. So points of inflection, what's the definition of inflection points? Go. You're correct. Inflection point is where f double prime sign changes. Sign change. And if you can't tell already, I'm using my mouse because I don't have my tablet in front of me, sadly. All right, so f double prime sign change means I'm looking at a graph of f prime. So the question now is, what is f double prime on a graph of f prime? Is it height, slope, or concavity? It's always one of those 3 things. And you should have answered that it's the slope, because I'm taking the next derivative to go into f prime, and taking the derivative on a graph means you're looking at the slope. So you're saying, where does the slope change on this graph? Well, the slope was it was positive over here, now it's negative, so it changes there. It's negative, it changes to positive, so it's each of these turnaround points. Oh, whoa, 2, 3, 4, 5, 6, and making sure that matches the interval 0, 8. Yep, sounds good. So the answer is 6. On to number 3. So we have the graph of the derivative right here, f prime, and we're trying to figure out which one could be the graph of f. We're going backwards with the graph. A little bit hard, but the key point here is that you're looking for all the information this graph is providing. Since it's a graph of f prime and it's going through 0, that means we have a f prime sign change. We have a positive to a negative. What is that? That's the definition of what? F prime changing from a positive to a negative. That should be a maximum. So changing from a positive to negative right here, there's a maximum at x equals -1. And changing from a negative to a positive, that's a minimum at x equals 1, positive 1. So this graph is off because it goes through 0, so it's not A. Looking at B, yep, you have a max and a minimum at those values, that's why it's the graph. Looking at C, I have a minimum and then a maximum, so it's backwards. D and E, they don't make any sense. You're taking the derivative again. We're supposed to go backwards. This was a positive quadratic. If you went forwards, that would be a positive linear. Good. This one's just totally wrong. Number 4. Which of the following could be the graph of h prime if that's the graph of f, or graph of h, I should say. So now we're taking the derivative of this. So notice that if I'm taking the derivative, h prime, let's look at h prime on the graph of h. So question is now, what is h prime on the graph of h? Is it height, slope, or concavity? You should have said it's slope. So let's look for where the slope is equal to 0. Slope is equal to 0 there and there. That means on the graph of h prime, I should go through 0. I should have a height of 0 on h prime. So which of these have a height of 0 roughly there and there on the x-coordinate? Well, that one only goes through the x-coordinate, or the x-axis once. That only goes through the x-axis once. That goes through x-axis twice, twice, twice. And then I guess the real key, how you could have done this really fast, is, oh yeah, that's a not a quadratic, that's a cubic. Not only is it cubic, if I look at the endpoints, I see that the slope would have been positive, which means it is a positive cubic. And when I take the derivative of a positive cubic, I get a positive quadratic. Well, that's not a quadratic. That's a quadratic, but it's negative. This is the only positive quadratic. I'm just going to say quad because I'm lazy. Perfect. That's number 4. Number 5. Which of these functions below is increasing at a decreasing rate? So increasing that means that the slope f prime, f prime is greater than 0, that's our definition, at a decreasing rate. So this is talking about the rate of the increasing, which means whenever you see the word rate, it always means take the derivative of whatever you're talking about. So take the derivative of f prime and you get f double prime. So that means f prime is greater than 0 at a decreasing rate means f double prime is less than 0. And I think this makes sense without even having to know the formal definition of increasing, f increasing and f concave up or anything like that. But it helps to analyze these graphs. So this one is increasing, but at an increasing rate because it's concave up. It's increasing because the slope is positive. It's concave up, which means it's increasing at an increasing rate, not A. B is decreasing at an increasing rate. It's positive. So it's decreasing. I think I'm saying that backwards. This might be for my sickness. I'm going to go ahead and blame that. But it's definitely decreasing because the slope is negative. And then the speed that it's decreasing is also decreasing as well, because if the speed was increasing at, okay, let me say this correctly. If this function was decreasing at an increasing rate, it would look something like this, and it would go faster and faster towards a negative infinity. So it's not B. C is the correct answer. It is increasing. It has a positive slope, and it is a decreasing rate. It is concave down. D is decreasing at a constant rate, not a decreasing or an increasing rate, because this is neither concave up nor concave down. The second derivative would have been 0. E is decreasing because the slope is negative, so it's already wrong, and it's decreasing at that increasing rate that I was trying to talk about for B. And we're on to the final problem, number 6. So we're looking, it also tells you that the horizontal tangent lines are at x equals -1. It tells you right here, x equals 1, lag here, and x equals 3. So those, by definition of the problem, are horizontal tangents, and we're looking for a relative maximum. Well, those don't really help us that much because this is a graph of f prime. The definition of f maximum is f prime does what? Do you know this one? F prime goes from a positive to a negative. So if we're on a graph of f prime, what is f prime? Is it height, slope, or concavity? You are correct, it is height. So you're looking for a height change from a positive to a negative. Here's a height change from a negative on the left to a positive on the right, so not quite key. This goes from a positive to a positive, so that's not even a critical, or it is a critical value because 0, but it's not a relative extrema. And then this one goes from a positive to a negative. That's the one we were looking for. It's only that one, only at 4. And that concludes the self-check. Go ahead and give yourself self-check 3.2, and I don't know how many questions there are. I think it's 6 again, I would guess. It's 2 minutes per question is the idea.